We've talked about maximizing utility given a Cobb-Douglas preference. What we'll talk about in this video is one of two special types of preference, which is the perfect substitute. Perfect substitutes, from the name itself, refers to the consumer being willing to substitute one good for another at a constant rate. As a refresher, the marginal rate of substitution in our Cobb-Douglas utility function changed as we consumed more of one good and less of the other, because the indifference curve in our Cobb-Douglas utility function was strictly convex. And the marginal rate of substitution is actually equal to the negative of the slope of the indifference curve. So if I were to take 2 points on the indifference curve of my Cobb-Douglas utility function, let's say point A here and point B here, I would see that point A, at the slope at point A, or the marginal rate of substitution at point A, is much greater than the marginal rate of substitution at point B, because the slope here is clearly steeper than the slope here, which looks a lot flatter. In the case of perfect substitutes, the marginal rate of substitution is constant, which implies that the indifference curve is linear. At any point of the same indifference curve, the consumer is willing to substitute good 1 for good 2 at the same rate. So if we were to draw our indifference curve of perfect substitutes, let's say that x1 and good 1 and good 2 are actually perfect substitutes. I'll use pink. Then the indifference curve here would look something like this. And so at any point along this indifference curve, marginal rate of substitution is the same. A good example here would be black pens and blue pens. So let's say that the consumer has to choose between black pens, so black pens, and blue pens. Here we assume that the consumer is not concerned about the color of the pen. Rather, he or she is concerned about how the pen writes. And for our example, both black and blue pens have the same quality for writing. So in this case, our utility function is u, which is a function of x sub 1 and x sub 2, is equal to the quantity of good 1 times the additional utility that the consumer gets as he consumes more units of good 1, which we will denote as A, plus the quantity of good 2, which is x2, times the additional utility that the consumer gains as he consumes more of good 2, which we will denote as B. So here, A is merely the marginal utility of good 1, and B is the marginal utility of good 2. And a while ago, we were talking about how the consumer is actually indifferent between black pens and blue pens. So in this case, the consumer gets the same level of utility with 1 additional unit of black pen or 1 additional unit of blue pen. So in this case, specifically this case, A is actually just equal to B. So I could rewrite our utility function, u x sub 1, x sub 2, is actually equal to ax1 plus ax2. And so now what we want to do is to find what our marginal rate of substitution is. And what we find is that our marginal rate of substitution, MRS, is 1,2 is just equal to mu1, or the marginal utility of good 1 over the marginal utility of good 2, which is just equal to the partial of u with respect to x1, which is a, over the partial of u with respect to x2, which is b, but a is equal to b, so this is also a. And so a over a is just equal to 1. And so the marginal rate of substitution in this specific case is equal to 1. And it is independent on X1 and X2. Meaning the MRS here is actually just a constant which does not change as we consume more or less of good 1 or good 2. So here, the consumer is actually willing to substitute one blue pen for one black pen at any point of the same indifference curve. Another example I want to give is notebooks. Say the consumer gains utility for every page of a notebook and has to choose between thin notebooks and thick notebooks. So thin notebooks and thick notebooks. The thick notebook has 2 times the number of leaves than the thin notebook. So in this case, the consumer would get twice the utility from the thick notebook compared to the thin notebook. So here, rewriting the general form of our utility function. So x sub 1 comma x sub 2 would be equal to a x sub 1 plus b x sub 2. So we'll assign the thin notebook. So I'll just write this on the right side. The thin notebook is good 1, and the thick notebook is good 2. So again, the consumer gains twice as much utility from the thick notebook than the thin notebook. So here, B is actually 2 times A. So B is actually equal to 2A. So rewriting our B in terms of A, our utility function would now be U as a function of x sub 1 and x sub 2 is equal to A x sub 1 plus 2A x sub 2. And finding our marginal rate of substitution, which is equal to mu1 over mu2, this would now be equal to A over 2A, which is equal to 1 over 2. So in this case, the consumer is willing to give up 2 thin notebooks for 1 thick notebook. Again, the definition of perfect substitutes requires that the marginal rate of substitution of the consumer is constant along the indifference curve. And we see here that our marginal rate of substitution is equal to 1/2 and is independent or not affected by the quantities that the consumer chooses. If the consumer were subject to a budget constraint, he would try to maximize his utility by finding which of the 2 goods would give him the most marginal utility per peso or per dollar. So it would simply be mu1 over p1 and mu2 over p2, and whichever one of these is greater, then the consumer would choose to consume that good only without consuming the other good.